the spaCy has always been very opinionated. We usually have like one implementation, and we want that implementation to be the best one, the one that generalizes, and the one that's most useful. So I would say that that's kind of the main difference, or especially initially in the design.
Hello and welcome to another episode of D4 Data Channel podcast. I'm your host Deepak. Today I'm joined by a special guest, Miss Ines Montani. So Ines is a data science rockstar and co-founder of Explosion, the creators of spaCy, Prodigy and THiNC. And I would like to welcome Miss Ines to this podcast. Thank you for accepting my invite, Ines.
Yeah, thanks for having me. I'm really excited.
Great. So I personally started my NLP career journey with NLTK and spaCy, and the first thing which made me really proud is actually like in my data science career was training a custom NER pipeline with the EN Core SM model. So today we'll be discussing a lot about the evolution of spaCy and other Explosion products mainly. So yeah, I'm pretty excited for this. So so my first question, so what was the initial design concept behind spaCy library?
Yeah, so spaCy was really designed to be used in industry and in like real products and real world use cases from day one. So my co-founder Matt, he was an academic, he was working on NLP, and he basically got the idea when he realized that companies wanted to use his research code in things they were building, because it was at that time when the technology slowly started to work and things were suddenly possible. But also, of course, research code is not meant to necessarily solve problems and be very easy to use. The research code is intended to print a number at the end and exit, because you're trying out different approaches and algorithms. So he was like, "Oh no, don't use my research code. That's bad." But it clearly showed that there was basically this gap for like a library that was really designed to be fast, which again is also not necessarily a concern in like academic codes and libraries and frameworks, and that also provided data structures and an API that people could work with and quickly build, kind of industrial strength solutions for NLP. And that was really from day one the design concept. It started just as a tokenizer, which is also where the name comes from, spaCy, and CY, because it's implemented in Python, which is Python with C extensions, and that means it can be very fast than just a pure Python implementation, and that's kind of the origin of it. And over time, of course, the library has changed a lot as also the technology and the field changed, and the use cases that people want to address with NLP.
Great to hear actually. So yeah, so talking about spaCy, like how much inspiration did you get from the NLTK library, and what was the turning point in spaCy?
Yes, NLTK, it's kind of a different library in a sense, because it was developed for teaching and research. That's its purpose. There's a book that accompanies it. A lot of students, especially back in the day, who started with NLP would have started with NLTK. It implements a lot of different algorithms, a lot of different models, a lot of different things you might want, and it's basically this collection that can be used to do different things. And so it's kind of a slightly different philosophy from spaCy. Like when we developed spaCy, the idea was always, we don't want to have 20 different implementations necessarily to choose from, where you just have to know that this is the good one you should use, and the other ones are kind of old things that you might want to try out and benchmark and compare and learn about. But here's the one you should actually be using if you want to do real stuff. That we didn't see that as very useful for the industry use case. So the spaCy has always been very opinionated. We usually have like one implementation, and we want that implementation to be the best one, the one that generalizes, and the one that's most useful. So I would say that that's kind of the main difference, or especially initially in the design.
Understood. That creates a lot of difference actually. And so out of the available English language model, this is something which I felt actually like regarding the EN Core, Web SM, MD, then LG, and even the TRF transform model. So I observed like spaCy covered all the important NLP architecture and models over the time. But is there any implementation which came out of like the structures which is of RNN and by LSTM, or like is it skipped, or like is it implemented internally
So I
in other packages?
think we might we might want to have some of these implemented in our machine learning library THiNC, but as I said before, like spaCy's design is quite opinionated. We try out different things. We see what works best for the individual components, and then that's what we use to power the models. And these what works best can also kind of vary by language. Like for example, spaCy's default tokenizer is rule-based. It uses, exception rules, splitting rules, and that works very well for languages where, that work this way. But of course, there are other languages like Chinese, for example, where white space is not really, doesn't really tell you much about what's a word and what isn't. And for that, for example, we want to, we have introduced an experimental component that can actually perform can be trainable, and that they're like very different trade-offs by language, by use case, by type of model, and that's also what we use to decide about the model implementation that we use. And we have our machine learning library that powers it, where we implement a lot of different options, and then you can also put them together. And especially in spaCy 3, we really made all of these parts even all the way down extensible, so you can easily say, hey, why not try out some different implementation? Or maybe there's something new, you read a paper and you read about like some new learning rate schedule or some new optimizer that you really want to try out. You can just implement that, but the defaults we provide, we try to come up with a good general purpose
Got it.
solution.
Got it. So like I'm very much impressed with the language support provided by the spaCy library, and how is it actually typically developed, and like do you seek the support from regional teams for this modeling?
Yeah, we've actually had some great contributions from the community, which is awesome. Like either individual developers or teams working on support for their languages. And usually, the first step is always to introduce the base language support and tokenization. Like often, languages have some special cases that need special tokenization rules that can be like easily written down. So we can support the basics. There are also other little, details about the language that can be provided. That's a really easy pull request to submit most of the time, and that's also where we see a lot of involvement from the community. So yeah, if you're listening to this and your language isn't supported by spaCy yet, that's kind of the first step, and it should hopefully be relatively easy to contribute, even if you're just getting started. And then the next part is, of course, training the components, and that in a lot of cases comes down to the available data. So, a lot of the corpora we train from were developed in academia. We do plan in the future to create more of our own annotations to work around a lot of the problems you otherwise have, because often the data resources are either not available or they're not distributed under a commercially friendly license. And that all means that, okay, if we do not have good resources that we can train from, then it makes it much harder to really provide a good pre-trained or like a good trained pipeline that we distribute. So that's kind of what explains what we support and what we don't. But there are a lot of new corpora that are coming out, and so the next step is often that maybe someone from the community runs some experiments. It's relatively easy now in spaCy 3. You can if you have stuff in the kernel format, you can convert that. You can you might have to tune some settings, run a training experiment, and if the results look promising, then that's super exciting. Often we do have people from the community telling us like, hey, I trained something for my language, results look good, here's a great new corpus that was released, and then we check it out. And if we can integrate it into our own build pipelines, then that means we can distribute a trained pipeline for it.
So out of curiosity, so out of all the languages, do you recollect any of the language actually created a lot of pain while creating these kind of models?
Yeah, sure. It depends on the data. Like what we want is the pipelines we distribute, we want a good general purpose pipeline. But of course, there are a lot of the most interesting use cases of NLP and the most valuable use cases also in industry are the ones that are quite custom and solve very specific problems. So, you might want to, analyze, data in Chinese or Hindi or even just English, but you want to do it for your really specific domain. And that's where it's also very important that you can either fine tune or just train your own pipelines on custom data that you have. And nowadays with transfer learning, if you start off with good embeddings, whether it's word vectors or transformer, or other pre-trained weights, you can actually achieve pretty good results with not so many training examples. So, one thing we always want to, make very easy, and a path that we want to, show people and make available for people, is the option to just label some of your own data and train a model to do really specifically what you want for your specific use case.
Okay, cool. So yeah, so my next question, so spaCy always adapts to the latest NLP trends, and spaCy transformers and tailored pipelines are actually big examples for it. So will spaCy eventually take over the path where the NLP toolkits should be developed, basically?
Oh, you mean that they don't need to be NLP toolkits anymore?
So will spaCy kind of lead that particular frontier in terms of the developments of these kind of toolkits?
I hope that people find spaCy useful and also find it very extensible so that it can cover their use cases. But that said, I think there will always be room for toolkits and libraries to tackle more specific questions and more specific types that people are doing. In the end, NLP or machine learning development, it's just a different type of development. And programmers will always program. There's always a need for doing things differently. So I don't think it's a really good goal to say, one library or one thing we're doing should be like the one size fits all solution for everything, because that's not realistic. And actually, often you see that when products are trying to do this or tools are trying to do this, that the result actually ends up worse. If you're trying to be everything, and you're trying to tell people, well, it's either all or nothing, people have to take nothing if they don't want all. Whereas, what we always want for our stack is we want it to fit nicely into people's workflows wherever they are. Like maybe people just want to use spaCy as a small component to do pre-processing. Maybe they want to use it as like the main framework for the application and then write some custom plugins for the pipeline to do different things. There are like tons of use cases. Maybe they just want to use some of our other tools independently. Like we really want this stack where you have individual pieces that work great together, but that you can also use separately, and that just, that you can program with and that just fit into your workflow.
Sure.
That's kind of the philosophy we have.
Yeah, so I really admit that actually, regarding that flexibility for us, to actually use the spaCy whenever we need, or in that pipeline where exactly it can be fit. So that particular approach is really, really great. And so now let's talk a little bit about the spaCy models and pipelines. So from prototypes to production. So how effectively we could use spaCy pipeline in the end-to-end MLOps cycle actually.
Yeah, so I think there's still a lot of work done on MLOps in general in the field, and I don't think we've reached a point where we found the one perfect solution that works for everyone. But I think already, the main prototype to production idea here is that we've always found that it's a problem if your development workflow for prototyping is super different from what you're actually shipping in production. And that's where a lot of the problems happen. Like if you have a developer who just hacks together some stuff in a Jupyter notebook and then passes that on to someone who makes it production ready, that can be a big problem, because you might actually end up building things that will not work later on. You're creating a lot of, the iteration cycle also becomes much harder. Like you often want to change one tiny thing in your production model and see how that does. So the philosophy here is to basically provide a framework that developers can prototype with, but that also very easily translates into shipping things for production. And, we have other tools within spaCy, like the projects system that let you, script kind of like a make file, a series of steps from pre-processing, data conversion, training, evaluation, visualization. So you can really, have this one, and the config system as well. You really define all your settings in one place, so it's very easy to reproduce it and iterate on your solution. So that's kind of the idea here. And I think the extensibility also means that spaCy can integrate very well with existing MLOps platforms or whatever people use. The idea, the concept of reproducibility, I think, is important here as well, because that's often the biggest problem. Like you want to make sure that you can rerun your training as many times as you need with the exact same settings, that you can very quickly figure out whether one change you did caused everything to collapse. And that's also, I think, a lot of the features in spaCy 3 kind of go into that direction. And yeah.
Great. So just curious, so would you would spaCy actually be competing with other cloud providers like Azure or AWS in this particular space of this MLOps ever?
I mean, I think in general, like trying to compete with cloud providers is like a terrible business model. Because I mean, it's a good, it's always a good question to if you're building something and you're like, oh, would AWS just, am I adding enough value? If you're not adding enough value and AWS can just, do the same thing, that's like usually a sign that like, nah, this is just not, this is not a great idea. But I do think, ultimately, yeah, there'll be, people will be using cloud providers, but there's a whole like, product side of things where, people want to use tools that are good. And that's also where we see ourselves fitting in. I don't think, just, doing anything in the cloud is like, that's also pretty boring thing to innovate. But I think there's a lot of developer experience, product experience, developer productivity, where there's a lot that can be done, and that also can be done on any cloud provider. We kind of want to be pretty agnostic there.
True, true. Yeah. So yeah, like recently there was a package called spaCy. So like where like spaCy actually meet the domain, or like domain centric spaCy models are actually being rolled out. So like what are the other different efforts which, such as spaCy, where spaCy actually is customly tailored for any specific domain?
Yeah, I think spaCy is also like, I think this is a great example of also the type of vision we have for the library. So that was a package developed by Alan AI initially, and the idea as well. It's a custom spaCy pipeline for the biomedical domain. There have been other projects as well, for example, for legal text. And various different other domains, and yeah, I think that is the sort of thing we want to enable with the library, because ultimately, it's not just about training, a different named entity recognizer on different data. There are so many other things that are specific about a domain you're working in. Like in legal text, for example, you want to be able to detect references to, I don't know, other legal proceedings, or court cases or something, and then you want to link them up with a database so you can quickly find, that's a reference to this thing, or the names of judges, and you want to resolve them, and stuff like that. Similarly, in biomedical domains, you have like all these different biomedical entities. You often have knowledge bases that you want to link them to. Like, it's one thing to extract something from text, but usually that's not the end game. Like, if you're actually doing real work, you then want to use that extracted information to do something with it, to put it like in context to the rest of the world, or your knowledge that you have, like a database, like something else. And that all needs to be very custom to the domain. And yeah, so I'm definitely excited about seeing more of these kinds of projects. It's also something we want to be working on more. Actually another awesome project, that's something we did, that's is called HealthC. That was actually developed by one of our machine learning engineers, Edward. He started it as part of his university bachelor thesis, actually, and then it evolved into a bigger project, and that analyzes health supplements. So check it out. It's on our blog. It's a really awesome project, and there's actually a really long blog post that really explains the design process, and how you need to approach custom pipelines for these different very specific domains, how to implement maybe very custom components that do stuff that you want to do. And yeah, with spaCy tailored pipelines, which is our services offering that we started recently, we'll also be getting a lot more insight into what people are doing and what companies are working on, and that can also inspire new components. And that was always the idea. Like, we realized, like, hey, if you're developing a library that people should use, you need to understand what they need, and you also need to be using your own software. Because if it's actually dangerous if you're just building software and you're not actually using it yourself, because there might be bugs, there might be inconveniences that you don't notice. And so we were like, we need real world. We want to provide better solutions for real industry problems. And so for that, we need to work on real industry problems. So that's why we launched spaCy tailored pipelines, and we already got a ton of really interesting projects. And it actually has already inspired various improvements to the library, and we want to keep that going. And I think this is a great way to also provide more value to the community, because spaCy as a library will benefit from that.
Great to hear, actually. Got it. So regarding the integrations and support, like so apart from the integration with open source platforms like Hugging Face and others, like are there any other integration with paid services that spaCy is actually being looking for?
Oh, I mean, there's some things we integrate with are like more, SaaS platforms. Like I think in the MLOps space, like sure, I think if you in for like individual projects, I think Weights and Biases is free if it's public. But like if you're using it as an organization, mostly people are on paid plans. I think there are a lot of these types of tools in the space that spaCy integrates with. We also have like there's a spaCy universe which shows plugins, but also other integrations and libraries. And I think some of these are more like SaaS products, which make sense for things like ops or I don't know, even hosting. And then there are other things which are just open source libraries. So we're kind of open to that.
Great. So yeah, so looking into the other products from Explosion, so like what could you actually give us a understanding about this THiNC platform?
Yeah. Yeah, so yeah, I wouldn't. I mean, it's mostly an open source library. I think I wouldn't say it was released that recently. It's actually, I think it's how long ago? A year and a
Okay.
half, 2 years. I mean, when we like actually released like the website for it. But a fun fact is that actually it has always powered spaCy pretty much since very early on because basically when we started implementing spaCy and the models for it. That was back before PyTorch was released. If PyTorch had been out and stable, we might have actually used PyTorch, but PyTorch wasn't there and TensorFlow wasn't really stable. So that's how we initially started writing our own neural network library. And then later on, it turned out that actually it's kind of a nice experience being able to just implement, your own model implementations as well as use implementations from other libraries because one problem I don't know, if you're using open source software, I think everyone's experienced like situations where you were working with two tools with conflicting dependencies, especially if, the tools like PyTorch, TensorFlow, if they have a fast release cycle, they changed a lot. It's super easy to end up being like stuck on that project with the old version and you can't upgrade but then you can't install this thing. And that can be a real problem and make development harder. So it was actually kind of useful not to have a fixed dependency on PyTorch or TensorFlow. It also makes the install more lightweight. It does mean we can do things a bit differently and have our own optimized implementations. We liked the functional style of writing neural network models, which was also great. Is also great for kind of really getting deeper into what we want to do. People on the team have even found it really helpful for learning. So that was kind of the initial history of THiNC, and it's pretty much always powered spaCy. And more recently, we released a new version which had which was kind of a rewrite from scratch and introduced a bunch of new features. And so we were like, let's make a website for it so people can understand how it works basically and how spaCy works under the hood.
Okay,
Yeah.
cool. So yeah, so could you talk a bit about your team at Explosion.ai?
Yeah, so we recently actually were able to extend our team and hire a bunch of really new cool people, which was great. So for a very long time, actually, when we started out, it was just mostly just Matt and me doing pretty much everything, and we slowly grew the team, and until quite recently, we actually had a very small team working on spaCy, Prodigy, and our other open source stuff, and now I think we're slightly over 30 people. We have people working on spaCy. We have people working on Prodigy, which is our annotation tool for creating training data for machine learning models, because we think that's a very important aspect, and that's also our first commercial product. And we also have people working on Prodigy Teams, which is our upcoming product, which builds on top of Prodigy and brings it into the cloud, but without compromising on data privacy and scriptability that people like about Prodigy. So we're working across a lot of different areas. We have people working on example projects, tutorials, things for spaCy, on the core library, on spaCy tailored pipelines, which is our services offering. And then we also have Prodigy and Prodigy teams. So that's kind of what people are working on.
Pretty cool actually. So, regarding the AI responsibility part, like, so any efforts done in by spaCy in this particular space to promote responsible and ethical AI, actually?
Sure. I think one thing that's important here is like you can have all kinds companies have all kinds of initiatives and you can talk a lot about like, oh, we care about like ethical things and we formed like a working group, or here's our like, I don't know, badge that we put on our website, or like I don't know. I think that's all like I don't know, we like to and we like to show and not tell in general, or we like to we actually like to have our the work we do kind of speak more for itself than like talking about how much we want to promote something. So I think one thing that's always been very absolutely clear and important in what we're doing is that people need to engage with their data. People need to create their own data. People need to engage with what their model is doing. The what the model is doing in the first place shouldn't be abstracted away. If you give someone just like a function, or don't tell people anything about what your library or what the underlying implementations and machine learning does, people, people will build solutions and don't understand them and don't, aren't actually, able to meaningfully engage with how, with how does the model work? What is it predicting? What do I do if it's doing something that I don't want? What are the risks in my approach? So abstracting away the complexities, I think, is one problem that, this can be prevented by like not doing that and by really giving people the full picture. And again, a lot of the work we do in the space of data annotation, data exploration, creating training data, iteration. I think that's a very important message. Like you need to, the developer needs to be engaged in the data process. You can't just throw your data over the wall to someone else, have it annotated, and then take it back and train your model, and then not actually look at what are you have to engage with the process of creating what your model's going to learn from, and by doing that, you will also be able to assess whether there are any risks and conflicts and problems in the data in combination with your model. A lot of that is also quite specific to the work you're doing. You can't like, yes, you can assess pre-trained weights and pre-trained models for these criteria, and I think that's important work. But ultimately, one model, the same model you train, could be really perfectly useful and great and completely unproblematic in one setting and absolutely horrifying in another. And I think that's also why you can't just decouple that. And I'm very skeptical of the whole, of this whole like trying to productize ethics. I think there are a lot of, also especially the big tech companies, they're really into the idea of like giving a stamp of like, here's our AI is ethical. And I think that's incredibly problematic. And I know why, of course I understand that companies want that. It's great. You don't have to worry about it because there's, the truth is that if you are engaging with it productively with your team, it means you do have to confront actual real problems. You also have to confront not only vague problems in the world. You have to confront your own very personal biases and your own personal misconceptions, and that can be painful. That's something people don't want. But I do think it's the way forward, and I think giving people tools to do that is, I think, a very important part of it.
True, true. I really agree to that point actually. So if developers are getting engaged with that data annotation and trying to understand the data at the initial stage itself, that can significantly reduce the bias actually, to be honest.
Yeah, I think it's one aspect. Like, I'm not saying that solves all the problems.
Yeah,
Like, there's a lot of great work. Yes, you can also approach it on the algorithmic level. You can approach it on all kinds of levels. There's even, there's not just the annotation. There's the data collection in the first place. There's like, how you even structure your team to work on things. Like, there's tons and tons of like aspects of it. But I do think, I also, yeah, I think it's not as simple as like, oh, scanning your model, putting a stamp on it, and calling it a day.
true. I moreover, that's actually a very big marketing strategy nowadays actually. So
Yeah.
yeah, that's there. So so my last question actually to so regarding the future of NLP. So what does the future of NLP looks like with spaCy, THiNC, and other pretty cool open source products which your team is actually been producing?
Yeah, I think in general, our view on NLP or AI has always been that it's a different type of development. It's not, but like years ago, people had this idea of like, who's going to win at AI? Is Google going to win at AI? Is China going to win at AI? Like kind of these sorts of, it takes, are we all going to buy our AI at the AI store? And I think what we've, seen, over the past couple of years, and I think what we'll also be seeing in the future is that it's a different type of development. We're already seeing companies have their own teams in-house. People are developing their own machine learning and NLP solutions, and so there won't be like one AI for everyone. There'll be a lot of work done by a lot of different companies, by a lot of different organizations, by a lot of different developers to solve their own very specific problems. And that's, I think, also something that we want to help with, and we want to help developers be more productive. For example, by providing better tools to do these things, to engage with the data, to scale up these projects, and to also make sure that things work, because ultimately that's kind of the bottleneck. Like you want to ship more successful projects, and you want to have fewer failed projects. You're always going to have failed projects, but you want to find out sooner whether your project's going to fail and focus on the ones that are not going to fail. That's how a lot of work works. And I think that's also how I see NLP development going forward. I think there'll be and I think there'll be a lot of new opportunities for building more products that help this sort of iterative development flow, because that's another thing I think that's important here. Is machine learning is code and data, and none of this is static. The code evolves and the data evolves, so you'll always be training new models, you'll always be trying out new things, you'll always be working on these things, updating it, and so there is constantly this need for iteration, and for updating, and for working on things. You can't just build your AI and then you're done forever. So and I think that's also why we think developer productivity is an incredibly important part here, and having good products that enable people to do cool stuff.
Great, great. So yeah, so that covers all my questions for today, Ines, and thank you very much for joining this particular podcast. And it was great to actually like listen to you about the perspective on like how spaCy is actually tackling all these NLP use cases and actually building a lot of pretty stuff or pretty cool models, so that like it really enables the developers or the practitioners to kind of build the enterprise ready product. So like that's products or like cool use cases, so that actually gives us a lot of flexibility for the developers in terms of building their own custom products and stuff like that. So really thanking you for all your efforts actually, and for your team as well. So yeah.
Oh, thanks. That's nice to hear. And yeah, thanks again for having me.